Okay, hello everyone. Hello Miss Wendy, hello students. So
Hi.
we're gonna start with our fourth workshop for today, which is on physics experiment.
All
So
right.
everybody can pay attention because this workshop has directly got to do with our video assignment, all right, with our second video assignment. So I'm gonna start. So first of all, our expectation settings. So if possible, I expect all the students to switch on your camera, and very importantly, when you're not speaking, please mute yourself so that there will not be any background interference with the other students. Next is please stay focused throughout the whole session. Participate, and the more questions do you answer, the higher the chance you have to win the Star Award. So yeah, we will be having the Star Award as usual this time. And this is our learning objectives for today. So first of all, to understand the theory behind physics principles. So if you do not, and next is applying the theory. So we will apply the theory into the assignment video. And thirdly, appreciating science. We'll marvel at what you can do by learning science. And finally, encouraging the youth to pursue a career in STEM. Because as we all know, working in STEM will honestly help our country to develop. So I'm going to start with mentioning the agenda for today. So first of all, there's going to be a brief introduction and check-in, followed by the density theory and our first experiment, and then activity one, and then it'll be the Newton's law theory and briefing on the second experiment choice. And then we'll have our interval for 10 minutes at 3:55. And after that will be our atmospheric pressure theory and activity two. And finally is the refraction of light theory and experiment, and followed by our last activity three, which is a Kahoot session. And finally, there will be a closing and Q&A session followed by a group photo. And yeah, and I would just like to tell early on, I will be reminding you guys later also that after our closing sessions, please do not immediately leave because we will be having our briefing for the group video assignment. So, so now we're gonna let the speaker one, Ashley. I'll pass the floor to Ashley.
Hi everyone. So my name is Ashley. I'm 21 years old. I'm currently doing my Bachelor of Business. I like true crime stories, horror movie, and books. And I'm also a Taurus in terms of horoscope. So that's my email address and my phone number. If any of the students want to reach out to me to ask me more questions about the topic that I'll be teaching today. So thank you. I'll pass it on to the next speaker.
Thank you, Ashley. I'll pass the floor now to Chris.
Hey everyone, I'm Christopher. I'm 19 years old and 6 months old. I'm studying law currently. I love watching Netflix shows and science fiction movies. I love tea, especially Earl Grey. So here's my email and phone number. If you need to contact me for anything, please do. I'll now pass it back to Yasha.
Okay, thank you, Chris. So I'm Yasha, and I'll be your third facilitator and speaker for today. So I'll be 20 this December, and I'm studying Bachelor of Laws at DLS. I have two cats and a dog, and I am a foodie. So this is my email address and handphone number. Feel free to contact or ask me any questions whenever you want, and I will reply you. So thank you. All right, so now we'll be moving on to the first topic of today, which will be done by Ashley.
Okay, so here is the first topic for today. That will be about the first physics experiment, which is density. So students, please pay attention because all the topics today will be important for your next assignment. I am a STEM nerd. So do pay close attention to everything that we'll be explaining. Okay, next slide. Okay, so what is density? Density actually has a few meanings. So the first one is density is the physical property of matter, as each element and compound has a unique density associated with it. The second definition is density is the measure of the heaviness of objects with a constant volume. And the third definition is density is how closely packed or crowded the atoms are in an object. But the overall formula that is associated with density is density equals to mass over volume. Next slide. So these are the key concepts of density equals to mass over volume that you guys will have to try to remember, because it'll be important when you do your assignment to explain these concepts in relation to the experiment that we'll show you later. So mass is the amount of matter in an object, and the only way to change the mass of an object is to take away a part of the object or add on to it. And volume is the amount of space occupied by a substance, while mass is the amount of matter it contains. And matter is anything that has a volume or a mass. For example, solid, liquid, or gas. So the takeaway is that if the amount of matter is increased without changing the volume, and then the density will increase. But if the amount of volume increases without an increase in mass, then the density will decrease. Okay, next slide. So let's compare the densities of solid, liquids, of solids, liquid, and gases. So solids have a higher density. This is due to the fact that their atoms are very packed closely together. And liquids have a wide range of densities that depend on the pressure that they're at, and they're usually very temperature sensitive. And gas has the lowest density because its molecules are not closely packed and they can freely move all around the atmosphere. But it also depends on the pressure and the temperature that is being put onto the gas. Okay, next slide. So let's compare the density of salt water and fresh water. So salt water is actually denser than fresh water. And the reason is that you need to remember again the formula density is mass over volume. So water that contains salt will have more mass, which will increase the density of the water. The higher the salinity of water, the higher its density will become. Salinity is defined as the amount of salt that is in the water. So salt granules break down and they go into the available spaces in the water molecules. And as they go into these vacant spaces, the volume remains the same, but the mass of the overall mixture of the salt and the water will increase in comparison to normal water that does not have any salt in it. So because of this, the density of the salt water will increase because it's been mixed up with salt granules that makes it denser. Next slide. So here are some real life examples of densities. So the ships, okay? So the reason that ships float is because there's air inside the ships that cause it to become less dense than the ocean water itself. So because of this, it's able to float above seawater. And another example would be helium balloons. Helium is a type of gas whereby the density is lesser than air. So when it's packed in a balloon, in the latex, it causes it to float. And another example would be ice and water. So you realize, right, your ice cubes, they always float on top of the water, but when they melt, they incorporate into the cup of water itself. So the reason that this happens is because when ice freezes, it traps air between its molecules, and this causes the ice to become less dense than the water, so it floats above the water. And finally, the last example would be oil and water. As you know, oil and water, they cannot mix because oil is less dense than water. That's why every time you try to mix it, when your mom is cooking in the kitchen, you go and play around and stuff, but the oil can never mix with the water. And the reason is that oil is generally less dense than water, so it always goes to the back to the top. Next slide. Okay, so here is experiment 1 that you guys would be able to choose among the rest of the experiments that we have today. So this is the first one, which would be about density. So here's what you will need. You will need 2 see-through cups, 2 eggs, water, salt, and a spoon to mix. So the first step that you need to do, you need to fill your first cup with water until it is almost full, and then place one egg into the first cup of water. And then you need to observe what will happen. And what should happen is that the egg will actually sink to the bottom of the water. So in the second cup, you need to fill it up halfway with water and then add 6 or more tablespoons of salt to the water in the container and mix it up. And once you're done mixing it up, add a small amount of water to the mixture, just a small amount. And once you've done that, place the second egg into the salt water mixture and observe what happens. So what should happen is that your egg will float above the water instead of sinking. So let me show you guys a video of how you can conduct this.
You've probably heard of a root beer float, but an egg float? You can try one for yourself with this experiment on density. To do this experiment, you will need 2 tall drinking glasses, 2 raw eggs, water, salt, and a spoon. Start by filling one glass almost to the top with water. Next, carefully drop an egg into the water-filled glass and watch what happens. You should observe the egg sinking to the bottom of the glass. Now, fill the second glass with water until it is half full. Next, add 4 tablespoons of salt to the second glass and stir. 1, 2, 3, 4. This is a safe experiment for small groups of students to complete on their own. Be sure students who handle the eggs wash their hands with soap and water after they finish the activity. Now we'll fill the second glass with water almost to the top. Finally, carefully drop the second egg into the salt water solution and watch what happens. You should see that you did indeed make an egg float. But how? The explanation is simple. In step 2, the egg dropped to the bottom of the glass. But in step 5, the egg floated. Why the difference? It's all about density. Density has to do with the amount of matter contained in a specific space or volume. Because the egg is more dense than the water, the egg pushed away water particles so it could make space for itself, thus sinking. When the salt was added to the water in the second glass, the salt dissolved into particles that bonded tightly to the water molecules, which packed more matter into the space. This makes salt water denser than regular water. The denser the liquid, the easier it is for an object to float in it. Now that you've seen for yourself how to make an egg float, can you explain why you can float more easily in the ocean than you can in a freshwater lake? Bet you can!
Okay, so now that you've seen how that you should conduct this experiment, let's try and figure out why this has happened. So an egg has a higher density than water, so it naturally won't float. But when we added salt to the water, however, we changed the density. We made it so that the water had a higher density than the egg. And because of this, the egg was able to float above the water. One point to really focus on is that an object doesn't have to weigh less than water in order to float. It just has to be less dense. This means that it has to have a greater number of pockets of empty space in relation to the mass. And this is how boats are able to float, despite being so large and heavy, and it's also why a ping pong ball will float, but an egg will not. So now I shall start the first activity. So activity 1 will be a guessing game of will it sink or will it float. So in this activity, students feel free to use the annotate where you can draw on the screen and tick the side that you think will sink or float. So can you guys try to draw on the screen? On any side, even the left or the right side. Can students?
Cannot lah. How ah?
Cannot
Mm.
Okay, so if that's the case, then students just answer in the chat box. Sorry?
I think is it enable us to share screen or something like that? It should be able actually.
It's okay then. If cannot, then students just answer in the chat box, left or right, okay, to guess which one will sink and which one will float. So please participate in this activity because you will still get the star points. And we forgot to mention that the top 3 winners of the star awards will actually get a gift that's sponsored by teacher Wendy. So do participate in the game so that you will accumulate more star points. Yeah. Okay, so let's start. Next slide. Okay, so here is a piece of wood. So guys, what do you think? Do you think that it will sink or will it float? So do comment left or right. Sink, okay. Left, right, left, right. Okay. Right. Okay, left. Wow, okay, it's pretty balanced out. Everybody is left, right, left, right, left, right. Okay. Okay, so left, okay. All right, okay, so let's see what it does, okay? So actually, when wood floats on water, it floats on water, guys. It doesn't sink. You know, I was very shocked when I found out that actually the reason that it floats is because that pieces of wood actually have more openings for air molecules to be trapped inside it. So as it decays, the wood will start having all the holes in it, and this causes it to be able to like trap air in it. So when this happens, the wood will float above the water because it's less dense than water. So it's all right. Good try, guys. Trisha, good guess. May, Miss Wendy also. Thank you. It's okay. I was like, what? It's okay. All right, next slide.
Okay, on this? No, nothing.
Okay. So styrofoam, guys, does it float or does it sink? What do you guys think? Okay, left, sink. All right, keep it going. Right. Okay. Float. Okay. Okay, so let's review the answer. Styrofoam will float. This is because the matter in styrofoam is not closely packed. So this makes styrofoam less dense than water. So there's a lot of air molecules trapped inside styrofoam. So this makes it less dense. So this causes styrofoam to float above the water. So all right, good try, guys. Okay, so this would be the last one. The next slide. So this one, can you guys see it? All right, so this one I actually mentioned just now. So let's see who was paying attention, okay? All right, so oil, does it sink or does it float, guys? What do you guys think? Does it sink or float? Float, 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 float. Okay, okay. Good, I can see everybody's paying attention. Okay. All right. So yes, correct. Everybody, oil does float. The reason is that the molecules that make up oil are larger than the molecules that make up water. So they cannot pack as tightly together as water molecules can. So because of this, they take up more space per unit area and oil is less dense than water. So it flows. All right. Good try, guys. Thank you for participating. Okay, so I'll pass it on to the next speaker, Chris. So thank you, guys.
Thank you, Ashley. Thank you so much for explaining density. So now I'll pass on the floor to Chris.
Right, thank you, Yasha. I will talk about Newton's law. Can you hear me? Okay, so next slide. Next slide. Oh yeah, thanks. So here are some important terminologies that you need to know before learning Newton's laws. The first one is force, which is quasar. It is the agency of change. It changes the velocity of the object, and it is measured in newtons, which unit is N. And the second one is mass, which is Newton. It is measured in kilograms, kg, and it is the measure of the inertia of an object. And now you might wonder, what is inertia? Inertia is the natural tendency of an object, of a body, to resist changes in motion. That's why when you car brake, your body will fall forwards because of inertia. And just to let you know, Isaac Newton invented all three laws. Next slide.
Just hold on a moment, please.
Right, sorry about that. So moving on, Newton's first law is also known as the law of inertia. It is explained as a body remains at rest or moves in a straight line at a constant speed unless acted on by a force. Force quasar is required when the object changes motion, and acceleration, which is permutation, is the observable consequence of forces acting. When you act on a force, it will accelerate. All right, next slide. Okay, so Newton's second law is the sum of forces, jumlah daya, acting on a body, tubuh, is proportional by qadar to the acceleration that the body experiences. Basically, when the sum of forces experienced by the body, it is proportionate to the acceleration that it experiences. This is why you get the formula, which is F equals ma, which means the force is equal to the mass times the acceleration of the object. Then the diagram shows a perfect example of this law in motion. Next slide. Here's an example video of this law. You can have a look.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Surely good show,
I don't
Sir
think we can
Isaac.
hear you.
Here we see that once the force of the thrust is
is it?
greater than the
Sorry.
weight of the vehicle, the rocket begins to accelerate.
All right, we're gonna start with something small. Something you might
Sorry, Chris, what is it?
Oh, no, it's okay. Sorry. Something is wrong on my end.
All right, I'll continue with the video.
have at home. A little stick of chapstick. We'll go ahead and use our force being our bungee cord here. We'll put it on our bungee and we'll pull it back. And go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel it, the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means acceleration is faster. This is the biggest and most massive thing we have. So let's see how the acceleration is affected. Pull back the same amount on the force. And here we go. And there you have it. Second law of motion. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
Chris, are you there?
Yeah. So I hope you enjoyed the video. So Newton's third law is basically action. So in the diagram, you can see both the women are pushing each other. As you can see, there are forces on both sides, and when there's an action, there's a reaction. So for every action force, there's an equal and opposite reaction force. This is the formula. Force of A is equal to force B. So
Diana, off the speaker. Diana, off your speaker. Yeah.
Students, please mute your mics when you're not speaking. All right, thank you. So I'm going to play the video, the next video. The workshop support team, please monitor who's not muted. Thank you.
Welcome to the International Space Station. I'm NASA astronaut Mark Vande Hei. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time, a force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. Got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied according to Newton's third law by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass. So Joe, get into a ball. I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
Okay,
Okay.
that was the video.
Yeah. So I hope now you understand the three laws of motion, and this is one of the experiments that you need to do, that you can choose to do for your assignment. It is about inertia. You will need a see-through cup, a coin, and a manila card. So the steps are: you lay the manila card on the top of the glass, have one edge of the card a little beyond the rim, so you can give the edge a good flick without smacking your fingertip on the glass. It is very painful. I've tried it. And place a 20 or 50-cent coin on top of the card so it's centered over the glass. Use your finger to flick an edge of the note card. You want to flick the card directly from the side. Do not flick it downwards or upwards by hitting from above or below the card. Then you can watch the penny drop straight into the glass. This is due to the inertia of the coin forcing it to fall into the glass. And why do you have to put it in the center? Is because when it falls into the glass, it will not drop outside of the glass. Next slide, you can show them the videos, the normal one and slow motion one. Okay, if you cannot see the video well because of the lag, it's basically just the coin falling into the glass. Because when you flick the card, the inertia will force the coin to fall into the glass, both at normal speed and slow motion. Slow motion is just to show you a better representation of what the experiment is about. Okay, next slide. Okay, back to you, Yarsha.
All right, thank you, Chris, for explaining about the Newton's law of motion. So now we'll be having our 10-minute interval. So feel free to take a break and come back in 10 minutes, okay? Thank you, guys.
Baby. Baby. Ni ba?
Okay, students, your interval is over. I hope you're all back because now we're going to continue. And before we continue, I request once again for all the students to please mute yourselves, like off your mic. Thank you so much for understanding. Thank you, guys. So yeah, now I will pass the floor back to Chris to do a short recap and then go on with his part. Yeah, thank you, Chris.
Right. So now I'll do a short recap in case it wasn't clear just now. Sorry for the interference. And so I talked about Newton's three laws. First law being the law of inertia, second law being F equals ma, and the third law being action-reaction, which is when two forces are acting together, there'll always be an opposite reaction force. And the experiment I talked about just now was about inertia. When you put a coin on top of a card above a cup, when you flick the card away, when the card is absent, the coin will fall into the glass instead of flying to the side alongside the card because of inertia, because inertia will push the coin into the glass. So now I will continue on with atmospheric pressure. Then I will talk about another experiment that you can also choose to do. So atmospheric pressure can be basically explained as, you see the column in the first picture, that is the top of the atmosphere, and atmosphere will exert pressure on a certain point on the surface, and that unit area, the pressure sustained, can be calculated. I will talk about the formula later, but this picture is not exactly accurate because atmospheric pressure is present everywhere, and each point of every surface is actually being pressure is actually being exerted on every surface on our planet. And atmospheric pressure is also can be also be described as in the second picture. Gas pressure depends on both density and temperature, and adding air molecules increases the pressure in the balloon. And heating the air also increases the pressure because the molecules will start heating each other more frequently. Next slide. All right, so this is the definition of air pressure. Gravity pulls the air molecules towards the earth, giving them weight, and the weight of the air molecules around us is called air pressure. And in this picture, you can also see at sea level, the air pressure is actually higher. And when you increase the elevation, the air pressure will actually be lower. That's why when you hike and you get to the mountaintop, you actually find it hard to breathe because the air pressure is lower there. And this is the formula I talked about just now, which is pressure equals the force divided by the area that it is being exerted on. And the unit is newtons per meter square. Air pressure is equal in all directions, as I've also said just now, which is on every surface, air pressure is actually being exerted. Next slide. Okay, so this is the third experiment that you can choose to do is by air pressure. You'll need just a bowl or bucket and a drinking glass. So put the glass into the bucket filled with water and turn upside down. Lift up the glass, but without the rim going above the surface of the water. Observe how the water level within the glass is higher than the water level of the bucket. Because the pressure of air on the surface of the water in the bowl pushes the water up into the glass. And if the rim of the glass were to be raised above the surface of water, air would enter and push it outside. If you lift the cup above the water level, the water will just drop back into the bucket. Then the glass will empty. Next slide.
Chris,
Yeah, I will do that right now. Just a moment, just a moment. Let me share screen. I'm not sure how to share the media file. Is that okay? No? Can you see my screen?
Yeah.
Okay, so here's the demonstration video for the air pressure experiment. Can you hear the sound? Okay, good. So as you can see, when I lift the glass, but not beyond the rim of the water level, as you can see, the water level in the glass is actually higher than the water level in the bucket. And here's a picture I've taken. This is what, and the reason why is because the air pressure is actually pushing the water in the glass to go up, and which explains the water level being higher than that of the bucket. Okay, so now moving on to the second activity, which is true and false activity. Just type in the chat box if you think this is true or false. T for true and F for false. Oh, sorry. Okay, so is this statement true or false? As elevation goes up, the air pressure goes down. I've actually talked about this just now. Is anyone paying attention? I can't actually see the chat box, but please answer in the chat box. If you think this is true, type T, and if you think this is false, type F. Oh, is it because you have seen the answer? Should we move on to the next question?
Students, you can type in your answers in the chat box. Do you think it's true or false? Please participate because you will get your star award for this.
Okay, it is indeed true. Yeah, because as I've said just now, air pressure actually is lower on higher elevation. Elevation meaning the height above sea level. Okay, let's move on to the second statement. So air pressure increases as height increases. True or false? This essentially means when it gets higher, it actually increases. I can now see the chat box. Good try, Logan. Please continue. Oh, sorry. It's false because it actually decreases when height increases because it is lower when it is higher, correct? That's why when height increases, the air pressure decreases. So the third statement, this is about the Newton laws. The higher the force, the higher the acceleration. True or false? Remember the equation F equals ma. So have a guess. Right, continue guessing. Any more guesses? All right, it is true. Because according to the equation, if you add more force, you will naturally get more acceleration. Okay, this is a simple one. So, does Newton's first law refer to the concept of momentum? Is it momentum? Do you remember? Have a guess. Right, keep them coming. Any more? Good. Mm-hmm. Okay. Ah, I see. Okay, it's actually false because the first law refers to inertia rather than momentum. Momentum is the second law. Okay, last one is maybe you've heard before the elephant and the feather, which one will reach the ground first? So a drop object which is heavier will reach the ground faster. True or false? See, the rock is so big, maybe it will reach first. I don't know. Do you think so? I see the answers are all leaning towards true. Any more? Okay, I'll now reveal the answer. It's actually false. This is because they'll reach at the same time, even though the heavier rock may experience 100 times the force of the smaller rock, it has also 100 times the mass. So the force and mass ratio is basically the same for both. So the greater mass of the larger rock requires the same amount of acceleration as the small rock to reach the ground. So yeah, they'll actually both reach the ground at the same time instead. Okay, so now I'll pass it back to Yarcha. Thank you so much for listening.
Okay, thank you, Chris. So now we have actually covered most of the topics for today: density, Newton's law, and atmospheric pressure. So now we are going to our final topic, which is light. So next slide, please. So in the light topic, we will actually be focusing on refraction of light more. But before we jump into that, I'm going to briefly explain what is light. So light or visible light is electromagnetic radiation that can be detected by the human eye. So as we know, there's like many types of electromagnetic radiation, but not many or not all of them can be detected by our human eye. So the visible light is the one which can. So electromagnetic radiation refers to the waves of electromagnetic field which is propagating through space, right? So as you can see, this is the speed of light, and usually it is simplified to 3 times 10 to the power of 8 meters per second, but this is the more accurate figure. Next slide, please. Okay, so this is the electromagnetic spectrum, which I was talking about earlier. So you can see all of these waves and X-rays and gamma rays. So the rainbow-like thing in the middle, that is called the visible spectrum, the one right below the light bulb. So yeah, that is the visible light, and that is what enables us to see. Next slide. Okay, so now we're going to go deeply into the refraction of light. So refraction of light is also known as the bending of light. So refraction is the bending of a light ray at the boundary of two medium. So when they say two medium, right, they mean two substance of a different density. So the light ray propagates from one medium to another medium with different density. So when light travels between two mediums of different density, this phenomena called refraction of light will occur. So light refracts as it passes from one medium to the next. The reason behind this is because it travels at different speeds through these mediums. So light travels faster in a less dense medium, and light travels slower in the denser medium. So basically, right, when there's two mediums of different density and light travels through it, the light will get refracted because the speed of light in each of the density is different. So if it's denser, it will be slower, and if it's less dense, the speed will be faster. Next slide. So light passing into an optically denser medium is bent towards the normal, while light passing into an optically less dense medium is bent away from the normal. So, okay, I want everybody to focus on this picture over here. So as you can see, the middle line is called the normal. So the normal is basically the reference point which you have to look at. And the incident ray is basically the light ray which is entering into the new medium. So from the original medium, right, it's entering into the medium of different density. So that's called the incident ray. So it's entering. And the light which is comes out in the new medium, which is the result of it, is called the refracted ray. So when it's going in, it's called the incident ray, and when it's going out, it's called the refracted ray. So what will happen is that when the incident ray is passing into a denser medium, it will bend towards the normal. So for example, like from less dense to dense medium, example is less dense is air and denser is glass. So say the light is moving from air into glass, right? So it will bend towards the normal. So when you bend towards the normal, it will go like, if this is the normal, it will go closer towards it. So the angle of refraction, it will be smaller. So, but if the light is passing into a less dense medium, it will bend away from the normal. So say that now it's upside down. It moves from glass to air. So it will bend away from the normal. So it will go like further away from the normal, right? So one is closer and one is further away. Next slide. Okay, so now we're going to talk about Snell's law. So Snell's law is a formula used to describe when the relationship between the angles of incidence between two different media. So basically, like the Snell's law is used for refraction. So when the light passes through two media, and there will be two angles, right? One is angle of incidence and one is angle of refraction. So Snell's law is a formula used to describe it. So the angle of incidence is for the incident ray, and the angle of refraction is for the refracted ray, all right? So Snell's law states that the value of the angle of incidence divided by the value of the angle of the refracted is constant for light passing from one given medium to another. So this is a formula actually. So sin I over sin R is a constant. So basically this formula, right, like the purpose of this formula, why it is made, is so that people can predict what will happen when refraction occurs between two mediums, so that they can just use the formula and they can predict the angle of incidence without actually carrying out the experiment. So where I is the angle of incidence and R is the angle of refraction. So this constant value, right, it is called the refractive index, yeah? So sin I over sin R is the constant value, and this constant value is called the refractive index. Next slide. Next slide. All right. Okay, thank you. So now we know about the principle of refraction. So basically, between two densities, different speed, refraction will occur. And to calculate the angle, they'll use Snell's law. So now we're going to talk about the application of refraction. So refraction is present in our everyday life. So the first example for this is light refracting from a glass bowl or a glass. So if you notice, right, when you take any glass and you put it near your face or something, the person on the other side will look at the glass, right? Your face will appear to seem much bigger than it actually is. And like for those of you who have a fish bowl, right? You know, like the bowl with a fish where you keep your fishes in it. If you put your face close to the bowl, you will notice that the fish actually looks bigger than the actual size. So this is actually due to refraction. So this refraction causes an object in the glass or bowl to look bigger and closer. So yeah, light which passes through a bowl, it gets dispersed, and therefore it looks bigger and closer inside the water. So what happens is, right, when there's this object inside the water and the light passes through the bowl, it will get refracted because there's two substances in that, there's the object and there's the water. So there's two substances, two different densities. So refraction will occur, and all these refracted light rays, right, there will be many, and it will all get dispersed like all over the place. So this will make it look bigger and closer. Dispersed means spread out, right? Okay. So this is the first application. Next slide, please. Okay, so another example of refraction is cameras. So I'm not sure if you all know this, but camera lens is spherical in shape, okay? whether it's the camera of your phone or the camera of like a DSLR camera, which you can see in this picture. All cameras, even the ones in your phone, is spherical in shape. So when you take pictures of something, the light waves are refracted from the object and it enters your camera by passing through the camera lens. Okay, so for example now, right, I'm using my phone to take a picture of something. So for example, I want to take a picture of my scissors or something. So the light from the scissors, it will travel to my camera. It will travel to my camera and it will travel through the lens, which is spherical in shape, and it will enter it, all right? So when it does this, refraction will occur. So light passing through camera lens, it will change medium from air and to the medium of a lens. So like from the object, the light from the object will travel through air and it will enter the camera lens, which is spherical. So as I mentioned, it's two different mediums and two different densities. So when this happens, the light waves will refract, and what the camera will do is that the camera lens will focus all this light into one point, and as a result, there will be the picture which is produced. Next slide. Okay, so this is our final example. So for those of you who wear contact lens, I'm not sure if you do. For those who wear contact lens, when a person with contact lenses, they view something, right? The light enters into his or her eyes after passing and refracting through the contact lens. So if you can notice from the picture, the shape of the contact lens is also spherical, you know, just like how the camera is like a curved shape, like a concave shape. This contact lens is also in a curved shape. So like now you're putting it into your eyes, right? So when you view something from this contact lens, the light, instead of directly entering your eyes, it will pass through the contact lens first. So the light will travel from the air into the contact lens, which is two different mediums. So refraction will occur. And so these lenses, they will focus the light, and these lenses are designed according to the patient's eye so that after getting dispersed and refracted, a person can see clearly. So that's the three examples. First of all, an object in a glass, a camera, and finally a contact lens. So there's many more examples out there which displays refraction. And yeah, next slide, please. Okay, so this is our final experiment, okay? This is experiment number 3, which is on refraction of light. So this is the light experiment. This is a very simple experiment, you guys. If you want to carry it out, you can even do it right now. It's very simple. All you need is a piece of paper, a marker, a glass, and water. So selai kertas, marker pen, cawan transparent, gelas, dan juga air. So what you do is you get a sheet of paper, right? Get an empty sheet of paper, and you draw 2 arrows on it. One arrow must be at the top of the paper, and another one near the bottom. So you make sure that the arrows point in the same direction, okay? And then you fill the glass with water up to the top. And after that, behind the glass, you slowly lower the piece of paper so that you can see it from in front of the glass. So you look through the glass of water and you watch what will happen. So this is the steps. It's very simple. I will show you the video on it, and so that you can understand better, okay? Chris can play the video.
To begin the experiment, you're going to need a plain white sheet of paper, and you're going to draw 2 arrows on it, one near the bottom section and one near the top. Now that we have our arrows drawn on our paper, you can see that they're both pointing in the same direction. When you have that complete, it's time to move to the next step. For this step, you need an empty glass cup, and you're going to fill that cup with water. You want to make sure that you fill the cup almost to the very top. For the next step, what you're going to do is you're going to position yourself so you're looking directly into the side of the glass. Then you're going to take your piece of paper and you're going to slowly lower it behind the glass, and you're going to watch to see what happens. Okay, now let's watch that again. Raise it up and then slowly lower it down. As you can see, the arrows are both pointing in the same direction. Can you tell me why, when we look at the bottom arrow through the glass of water, does it change direction?
Okay, thank you, Chris. Next slide, please. So as you can see right from the video, at first when we draw the two arrows on the
Beginning
paper,
pyramid, you're
it's
going to
both.
plain white sheet of paper, and you're going to draw two arrows on it, one near the
Um,
bottom section and one near the top.
Sorry, guys, just hold on for a moment. All right, okay. As you can see, when you draw the arrows on the original paper, it's both pointing towards the same direction, right? But then suddenly it's not, it's inverted. So you might be wondering, why did that happen? Is that like magic or something, right? Because originally it was both pointing towards the same and then suddenly it's different. So actually, guys, it's not magic, it's just the refraction of light. And I'm going to explain to you the concept behind why that actually happened. Okay. Okay, so during the experiment, right, the light traveled from the image through the air and then through the glass cup into the water. Okay, so I know that sounds confusing, so try to catch me again, okay? So this is the cup, right? Okay, just pretend this is a glass. This is a cup, and then there's a paper behind. So what will happen is that the light will travel from the image in the paper through the air into the cup and then into the water. So the light will travel once, and then after that, it will travel again out of the cup into the air, and once again, and then it will reach our eyes. So there's two process. One from the image into the water in the cup, and then second is after into the water into the cup, and then into back into our eyes. All right. So light refracts as it passes from one medium to the next because it travels at different speeds through those mediums, as I've mentioned earlier. So light travels fastest through air, a little slower through water, and even slower through glass. So what happens here is that, okay, when the light travels through the glass cup and into the water, it will bend once, okay? Light bends once when it travels through the glass cup into the water, and then it bends again when it travels out of the glass cup and into the air. So basically light bends twice, okay? So first from the glass cup into the water, light will bend once, and then going outside, it will bend again. So it bends twice. So because it bends twice, right, the light will cross paths, okay, because it's bending in different directions. So like one is, okay, just like assuming one is bending this side and the other is bending this side. So as a result, the light path will cross each other, and this will cause the image to appear to be flipped horizontally, so from left to right. So actually why it flipped is because of refraction, which causes the light to bend and cross paths. So yeah, next slide, please. Okay, so this is our final activity for today, which is a Kahoot. So what we're gonna do is that we're gonna paste the Kahoot link in the chat box, and then you just have to enter the code shown on the Zoom screen. So I will display a code on the Zoom screen, and then you enter the code. Okay, so I think there was a bit of confusion in the last session, right? Okay, actually, right, the questions for the Kahoot will be displayed on the Zoom, but the answers will be displayed on the actual Kahoot screen. So to know the questions, you have to look at Zoom and answer it through Kahoot, all right? So I will share screen now. Can one of the workshop support team share the Kahoot link in the chat box?
Bukan aku yang tak nak pergi COD.
Sama
dengan dua-dua COD kan.
So you can enter the game pin shown on the screen. Let me just type it back in the chat box, okay? I think there should be around like 10 to 12 of you. So we're going to wait for a few minutes, okay? Who is not in? I think Jihan isn't in, right? Jihan, Trisha. Yeah. Okay, I think that's most of you guys. I think all of you are in, except for Trisha. Can you try and get in? We will give you guys another 2 minutes, all right? And then we're going to start the game. Oh, okay, that is okay. Got it. So 1 more minute, huh? Okay, I think I'm gonna start because there's already 10 people. So this is the first question. Why does ice float in water? Okay, good. Like more than 50% of y'all got it right. Let's see. Okay, congrats, Yogesh. That's very good. Okay, so question number 2. Yogesh, Jehan, and Iskandar. Good job. What is the formula of density? Okay, very good. That's an improvement. Okay, so this time it's Yogesh, Jay, Mia. Okay, Maha and May. Good job. Y'all are keeping up. Y'all are close. Okay, so next, question 3. Arrange the states of matter from densest to least dense. Come on, guys. Okay. Let's see. All right, congrats. You guys got a streak, and now it's Jay and Jihan, top 3. Okay, 4th question. Why did the coin fall into the glass during experiment 2? So I hope you remember this was Chris's experiment. Come on, you guys. Okay, that's very good. I'm very happy. Most of you all got it right. Congrats, guys. So now it's Jay at the top. It's getting very competitive. Okay, come on, Maha and Mia, y'all are really close. fifth question. Who came up with the 3 laws of motion? Okay, this is an easy question. Okay, good job, Isaac Newton. I'm happy to see that most of you were paying attention. Oh, very good. Okay, Miss Wendy is back up. Hi, Miss Wendy. So, Jay, Jihan, Yogis, Miss Wendy, and May. Good job, you guys. And to all of y'all, keep on going. There's like 4 more questions, okay? Sorry, 5 more questions. Is the air pressure higher or lower at the mountain top? Okay, so let's see. Okay, good job. So next question. Question number 7. F equal to ma is from which law? Okay, come on, guys. Okay, who answered constitutional and administrative law? Guys, that is not physics, okay? That is law subject. It's okay, never mind. Just pay attention more next time. It's okay. So for the top 5 here, congrats. Next question. Which of the following is not an application of refraction? Basically, which one did I not talk about just now? Okay, good. Okay, good job, guys. Okay, question number 9. Arrange the speed of light in the following mediums from fastest to slowest. Okay, only 3 of you all got it right. It's fine. It's a bit confusing, right? So let's see. Okay, so Iskandar is back. Is up now. He got it straight. Now it's Jay, Jehan, Wendy, Miss Wendy, Iskandar, and Yogis. Okay, our final question. Everybody sit tight. Our final question. Get ready. An easy one. Refraction of light is also known as. Okay, I mentioned this early on during my part, if you can remember. Okay, yes, it's the bending of light. Okay, let's see who's the winners. Okay, Miss Wendy. Jehan, congrats. And Jay, okay, congrats guys. So runner-up is Iskandar and May. I think all of y'all are science nerds, right? Y'all probably love science a lot. And yeah, Yogis and all of you guys did really well. Congrats. Okay, good job everyone. So I'm happy to see that y'all paid attention. So yeah, I will be back to sharing the screen, okay? I will share the screen. Okay, so So that now our Kahoot session has ended, right? We are going to go to the present giving session, the award giving session. So we're going to know who won the Star Award this time. Okay, so J is Jack. All right. Okay, good job, guys. Good job. Okay, so I'm sure we are all excited. Let's see. Okay, so this is the winners for today for the Star Awards. Congratulations. Number 1 is Trisha. Number 2 is May. And number 3 is a tie between Jehan, Logan, Andy, and Maha. So I think 6 of you all are on the podium this time. All of you all participated really well. So congrats, you guys. All of you all will stand a chance to win our special present. And don't worry, we will take account of all the workshops, all 6 workshops. So a round of applause for your friends. Okay, thank you, guys. So yeah, now is our picture session. So this marks the end of our workshop, but do not leave yet because there's still a few things which we need to do. First of all, starting with our picture. So everybody please turn on your cameras. We are going to take a picture. Okay. Who's taking the picture, by the way?
I'm taking the picture.
Okay, thank you, Jingro. You can tell us.
Oh, Yasha, can you please stop sharing your screen?
Okay, sorry. Okay.
Hello, Andy, Trisha. Can you guys please switch on your camera? Waiting for 4 more person. Hi, Trisha. Are you here?
Yeah, I'm here. Wait, teacher.
Jack, can you on your camera?
Jack, are you here? Hi.
May tak nampak muka, May.
Okay, so everyone be ready, yeah? 3, okay, 3, 2, 1. Yeah, okay. Thank you. Okay, now I will paste the link. So you guys please fill the Google survey form first before you guys leave. Thank you.
Students,
guys.
Is there any briefing?
yeah, there's a
Yes.
briefing on leave.
Before the briefing, all the students please complete their survey form. We will paste the link in the chat. So first, we complete the survey form and then we will move on to the briefing. Yeah. Yeah, so Jingle have posted the link. We're going to give you all a few minutes to do this feedback form. If not, you can just do it later on. And then I will now pass the floor back to Ashley because Ashley is going to conduct the briefing, okay? Thank you, guys.
Hello guys, sorry, can you guys please switch on your camera again? Because just now I paste the link, then I haven't pasted the picture yet. So sorry.
Oh, okay. Sorry, guys. We need to take another picture. There were some technical problems. So just on your camera one more time. Thank you.
Sorry, students. Trisha is so cute. Hi.
Thank you, teacher.
Out.
Okay, Maha, buka kamera.
Jaga, Maha, Logan. Please on your cameras, yeah?
Jack.
Yeah, okay. Three,
Good.
3, 2, 1. Okay, yeah, okay, ready. Thank you.
You are welcome.
I'll start the briefing, can I, Arsha?
Yeah, go ahead.
Okay, so guys, please pay attention. So this will be about your second assignment, which will be called I am a STEM nerd. The due date will be the 3rd of February 2021 from 10 a.m. to 10 p.m. Yeah. Okay, so the scope of the workshop is basically like what you guys will have to do is record yourself showcasing one experiment from workshop 4, which is the workshop today. You know, we showed you guys 4 experiments. You need to pick one experiment and given 2 options, but you must pick one option of how you'll be showcasing the experiment. So the experiments will be among these 4. You have to pick one that you want to choose to show in the video. So the options of how you will be showcasing your experiment is number 1, either you can draw the experiment on mahjong paper or manila card in the format of an infographic. And the drawings need to be detailed and you will need to explain the theory of the experiment while showcasing your infographic drawing. Or you record yourself doing the experiment itself, the one that we showed, like you record yourself doing it. And while you do it, you need to explain the steps and the theories to justify what exactly is happening. So to explain this in Bahasa Melayu, if you all don't understand, so for pilihan 1, you need to lukis eksperimen tersebut pada kertas mahjong atau kertas manila dalam format infografik. Lukisan anda mestilah dilukis secara terperinci dan anda harus menerangkan teori eksperimen tersebut apabila mempamerkan eksperimen anda dalam video. Ataupun pilihan kedua, where you rakam diri anda melaksanakan eksperimen fizik yang dipilih. Semasa melakukannya, anda haruslah menerangkan langkah-langkah membuat eksperimen tersebut dan juga teori tentang apa yang sedang berlaku dalam eksperimen tersebut. So the requirements of this assignment is that this is an individual assignment. So you will need to record yourself, you will need to be showing your face, and you will need to be speaking in English. And the assignment will be based on the STEM skills presented in workshop 4, which is today's workshop. And you need to show yourself throughout the video. And the assignment will be limited to 4 to 5 minutes only. And it is compulsory for you to use English. So you need to choose one experiment out of the 4 and one method of showcasing, which is either you draw it on manila card or you do the experiment itself. You do it actually and you record while you're doing it, you explain what's happening, the theory of what we taught today. So this is the summary. So number 1, pick an experiment from workshop 4. Pick a method, either option 1, manila card, infographic, or option 2, doing the experiment. And then record yourself explaining the experiment in English. So the submission due date is the 3rd of February from 10 a.m. to 10 p.m. So does anybody have any questions?
No.
Okay. Anybody want to ask? You can ask now so I can help you guys now. Everything okay? Okay, and maybe you're shy to ask. Okay, anything, y'all can just reach out to us on WhatsApp and like how you guys did lah. Y'all ask us on WhatsApp and we'll explain to you guys personally lah. So don't worry, just kalau ada apa-apa soalan, tanya je kat WhatsApp, okay? And yeah, so that's it. That's the briefing. So we will send this brief to you guys in the WhatsApp chat to refer to it. So yeah, that's all. So you guys can leave now, and thank you for coming. Thank you for participating, guys.
Bye, everyone.
Bye.
Bye. Thanks so much.
Hey, teacher. Thank
Thank you,
you.
guys.
Bye. Thank you, teachers.
Bye bye.
Guys.